Today we're going to take a look at scatter plots. What scatter plots do is show you if there's some sort of relationship between two data values. So you create a coordinate plane and you plot your data values on the coordinate plane, and then you can tell if there's any sort of relationship between the two data values. That would be called correlation. Two types of correlation, positive and negative. Positive correlation would be as one type data value increases, so does the other. So for example, as you get older, your shoe size gets bigger. There's a correlation between your age and your shoe size that's positive because they both increase together. A negative correlation would be when one data value increases, the other decreases. So notice for positive, they both increase or they're doing the same thing. For a negative correlation, they're doing opposite things. So careful, a lot of students tend to think that a negative correlation is when they both decrease. That's actually still a positive correlation because they're doing the same thing. So when they do opposite things, for example, the outside temperature increases and your heating bill decreases. They're doing opposite things, so that would be a negative correlation. There's also a possibility that you have no correlation, no relationship between the data values, and that's when the scatter plot has points kind of all over the place. Typically with a scatter plot, we will create a line of fit, and that's a line that goes through the center of the data. And then you can use that line to make predictions about the data. Finally, there could be a causal relationship between the data. When a change in one data value forces the other data value to change. So for example, the longer you work, the more you earn. That's a direct causal relationship. The more you work causes you to earn more money. But what you have to be careful of is that correlation does not imply causation. What that means is that just because there's a relationship between two data values doesn't mean that one of them has to cause the other one to happen. There could be a third data that causes both of them to happen. So first we're going to just take a look at identifying types of correlation based on a scatter plot. So our first scatter plot is the length of time that you study and your test score. So first of all, when we look at the scatter plot, it kind of looks like they're both increasing together. If we were to put a line through the data, the line would have a positive slope. So there is a positive relationship between study time and test score. The longer you study, the better your test score. And that is the second part of our directions, interpret the correlation using data values. So the longer you study, that's study, better test score, or higher. Now, there's also, you can talk about whether or not the relationship is a strong correlation, a weak correlation, or kind of a moderate correlation. So I'm going to get rid of my line here so we can maybe see. Shoot, I can't because those were plots. Okay, so if you look at those points kind of all over the place, I would say this is a moderate correlation because if you look, some of the points are kind of far from my line. When all of the points are really close to your line of fit, that's when you have a really strong correlation. Some of them are fairly close to the line, so I would call it moderate versus weak. All right, taking a look at our second example, we have number of siblings versus GPA. And we've got these data values all over the place because the number of siblings has no relationship to your GPA. So this is no correlation. And again, what I said about the siblings and GPA is the interpretation. There's no relationship between number of siblings and GPA. All right, so our last example here, we have your time on medication and your illness symptoms. And as you can see, the longer you're on medicine, so here's our interpretation, the fewer symptoms you have of your illness. So this one would be a negative correlation because the time on medication increases as the illness symptoms decrease. They're doing opposite things. And that's our interpretation again. All right, so your time on medication decreases your symptoms. And if you think about maybe trying to put a line through this data set, that's a pretty strong relationship. All of those data values are very close to the line. So this would be what's called a strong correlation.